From launching its first rocket from a repurposed church to successfully landing on the lunar surface, India's space program has traveled an awe-inspiring trajectory. In just a few decades, the Indian Space Research Organization, or ISRO, has transformed from a fledgling agency to a global space powerhouse. Today, ISRO stands shoulder to shoulder with the world's leading space agencies, boasting achievements that include launching satellites, exploring the Moon and Mars, and developing independent human spaceflight capabilities. ISRO's success has ignited the imagination of millions, inspiring generations of scientists, engineers, and dreamers. The seeds of India's spacefaring dreams were sown in the visionary mind of Dr. Vikram Sarabhai. In 1962, just a few years after India gained independence, Dr. Sarabhai established the Indian National Committee for Space Research, or INCOSPA, the precursor to ISRO. His vision was clear: to leverage space technology for national development, addressing crucial areas like communication, education, meteorology, and resource management. Dr. Sarabhai advocated for a frugal approach, emphasizing indigenous development and innovation over expensive off-the-shelf solutions. On November 21, 1963, from the coastal village of Thumba in Kerala, India embarked on its maiden space voyage with the launch of the Nike Apache rocket. This humble launch heralded the rise of a spacefaring giant. Nestled amidst the swaying coconut groves and fishing villages along India's southern coast lay Thumba, a seemingly unremarkable location destined to become the launchpad for a nation's spacefaring dreams. Dr. Vikram Sarabhai chose Thumba for its proximity to the Earth's magnetic equator, offering a unique advantage for launching sounding rockets used for atmospheric research. With limited funds and infrastructure, the early pioneers at ISRO had to improvise and innovate at every turn. The launch pad was constructed using readily available materials, with local fishermen lending a helping hand. A dilapidated church was converted into an assembly and testing facility. Despite these humble beginnings, the spirit at Thumba was one of unwavering determination and infectious enthusiasm. November 21st, 1963, dawned bright and clear over Thumba. On the launch pad stood a slender, two-stage sounding rocket named Nike Apache, borrowed from NASA under a collaborative agreement. At precisely 6:25 p.m., the countdown reached zero, and with a deafening roar, Nike Apache pierced the evening sky. The rocket, carrying instruments to study the upper atmosphere, soared to an altitude of over 200 kilometers before splashing down into the Arabian Sea. The successful launch of Nike Apache marked India's entry into the elite club of spacefaring nations. It demonstrated that even with limited resources, India could make its mark in the realm of space exploration. The success of Nike Apache was just the beginning. In the years that followed, Thumba witnessed a flurry of launches as ISRO embarked on an ambitious-sounding rocket program. These rockets, though modest in scale, played a pivotal role in laying the foundation for India's future space endeavors. The early-sounding rocket program served as a training ground for Indian scientists and engineers, providing invaluable experience in rocket design, fabrication, testing, and launch operations. Each launch yielded crucial data and insights that helped refine ISRO's technological capabilities. The Rohini and Manaka rockets, designed and built entirely in India, became symbols of ISRO's growing self-reliance. While sounding rockets provided invaluable experience, ISRO had set its sights on a far more ambitious goal: launching an Indian satellite into orbit. This dream became a reality on April 19, 1975, with the launch of Aryabhata, India's first foray into the world of satellite technology. Named after the renowned 5th-century Indian astronomer and mathematician, Aryabhata was a testament to India's rich scientific heritage and its aspirations in space exploration. Though the launch itself was conducted by the Soviet Union, the development of Aryabhata was a purely Indian endeavor. Aryabhata's launch was a defining moment for India's space program, inspiring a generation of scientists and engineers. Having tasted success with Arabat, ISRO set its sights on achieving complete self-reliance in space exploration. Thus began the challenging yet ultimately rewarding journey of the Satellite Launch Vehicle, SLV. The SLV project was a monumental undertaking for ISRO, pushing the boundaries of India's technological capabilities. Engineers and scientists worked tirelessly, overcoming numerous technical hurdles and setbacks with unwavering determination. The SLV-3, carrying the Rohini technology demonstrator satellite, lifted off on August 10, 1979, but a technical malfunction prevented the satellite from reaching its intended orbit. Undeterred, ISRO meticulously analyzed the failure and incorporated valuable lessons into the next iteration of the SLV. The setback with SLV-3 only strengthened ISRO's resolve. The agency embarked on developing the Augmented Satellite Launch Vehicle, or ASLV, designed to carry heavier payloads into orbit. The ASLV featured significant design improvements, including strap-on boosters for increased thrust and an improved guidance system for greater accuracy. The first developmental flight of ASLV in 1987 faced a similar fate to its predecessor, failing to reach orbit. However, ISRO persevered, and in 1992 the ASLV successfully placed the Saros-C satellite into orbit. This hard-earned triumph marked a turning point for ISRO, demonstrating an unwavering spirit of perseverance. As the new millennium dawned, ISRO set its sights on even bolder ambitions, venturing beyond Earth's orbit to explore our celestial neighbors. In 2008, India embarked on its most audacious mission yet, Chandrayaan-1, a robotic lunar orbiter. The mission's primary objective was to conduct a comprehensive study of the Moon's surface, mapping its topography, mineralogy, and searching for evidence of water ice. On October 22, 2008, Chandrayaan-1 launched atop ISRO's Reliable Polar Satellite Launch Vehicle, or PSLV, and successfully entered lunar orbit on November 8, 2008. Chandrayaan-1 carried a suite of 11 scientific instruments, including those contributed by international partners, underscoring ISRO's growing role in global space exploration. While Chandrayaan-1 was still orbiting the Moon, ISRO was already setting its sights on an even more daring target, Mars. The Mars Orbiter mission, or MOM, also known as Mangalyaan, was conceived as a technological demonstrator, showcasing India's capability to design and execute interplanetary missions. ISRO achieved this feat on a shoestring budget of just $74 million, making it the most cost-effective Mars mission ever undertaken. On November 5, 2013, Mangalyaan embarked on its journey to the Red Planet, and on September 24, 2014, it successfully entered Mars orbit. The mission's success established India as a serious player in interplanetary exploration. Emboldened by the successes of Chandrayaan and Mangalyaan, ISRO set its sights on an even more ambitious goal, sending humans into space. The Gaganyaan program, announced in 2017, aims to launch India's first crewed spaceflight by 2025. Gaganyaan, meaning sky vehicle in Sanskrit, is a complex and challenging undertaking requiring the development of a host of new technologies and infrastructure. ISRO is developing a new crew module capable of carrying 3 astronauts to low Earth orbit and back safely. Beyond Gaganyaan, ISRO has outlined a series of ambitious long-term goals, including a mission to Venus, a space station, and even a human mission to the Moon. While ISRO's forays to the Moon and Mars have captured the world's imagination, the agency's fleet of Earth observation satellites plays a critical role in improving the lives of millions on Earth. These satellites, equipped with sophisticated sensors and cameras, monitor our planet's health and aid in a wide range of applications. They provide crucial data for forecasting cyclones, monitoring floods, assessing drought conditions, and mapping forest cover. Farmers use the information to make informed decisions about crop planting and irrigation, while disaster management agencies rely on it to issue timely warnings and coordinate relief efforts. ISRO's commitment to societal applications is evident in its policy of sharing satellite data freely with other government agencies and research institutions. In a country as vast and diverse as India, bridging the digital divide is a national imperative. ISRO's constellation of communication satellites plays a pivotal role in connecting remote corners of the country, enabling access to education, healthcare and economic opportunities. From broadcasting television signals to remote villages to providing internet connectivity to underserved areas, ISRO's communication satellites have transformed the media and telecommunications landscape in India. Recognizing the importance of space-based communication infrastructure, ISRO continues to expand its satellite fleet to meet the ever-growing demands of a digitally connected nation. Section 3, Precision from the Heavens, Navi-C, India's homegrown navigation system. Joining the ranks of an elite group of nations, India established its own regional navigation satellite system, Navi-C, or Navigation with Indian Constellation. This independent system provides accurate positioning, navigation and timing services, reducing India's reliance on foreign systems like GPS. Navi-C comprises a constellation of 7 satellites strategically positioned in geostationary and geosynchronous orbits, providing coverage over India and its surrounding region extending up to 1,500 kilometers. This system offers 2 levels of service: standard positioning service for civilian use and restricted service for authorized users like the military. The applications of Navi-C are wide-ranging, including terrestrial, aerial and marine navigation, disaster management, vehicle tracking and precision agriculture. Fishermen, for instance, can use Navi-C receivers to venture further into the sea with confidence, while hikers and trekkers benefit from improved location accuracy in remote areas. The development and deployment of Navi-C highlight ISRO's commitment to technological self-reliance and its ability to develop complex space systems independently. This achievement has positioned India as a leading player in the field of satellite navigation. Gaganyaan, India's ambitious foray into human spaceflight. ISRO aims to launch Indian astronauts into space, marking a pivotal moment in the nation's technological journey. The mission represents engineering, human endeavor, and scientific exploration. It involves developing a human-rated spacecraft for low Earth orbit. Gaganyaan embodies the aspirations of a nation and the dreams of generations. It signifies India's determination to push the boundaries of human potential. The mission's success will elevate India's stature in the global space community. Unveiling the mysteries of Venus, the Shukan mission. Venus, Earth's enigmatic planetary neighbor, has long captivated astronomers and planetary scientists with its scorching temperatures, dense atmosphere, and volcanic landscapes. Building upon its legacy of interplanetary exploration, ISRO is gearing up for Chandrayaan, a mission dedicated to unraveling the mysteries of this enigmatic world. Chandrayaan, meaning Venus craft in Sanskrit, aims to delve into the heart of Venus's atmosphere, studying its composition, structure, and dynamics. The mission will investigate the factors contributing to Venus's runaway greenhouse effect, providing valuable insights into climate change and planetary evolution. The spacecraft will be equipped with a suite of sophisticated instruments, including radar to peer through Venus's dense cloud cover, spectrometers to analyze atmospheric composition, and cameras to capture high-resolution images of the planet's surface. The data gathered by Chandrayaan will help scientists piece together the geological history of Venus and shed light on its evolution over billions of years. As ISRO prepares for this challenging mission, the global scientific community eagerly awaits the wealth of knowledge Chandrayaan promises to unveil. The mission's findings will not only deepen our understanding of Venus, but also provide valuable insights into the formation and evolution of terrestrial planets, including our own. Reaching for new heights, ISRO's vision for a space station and beyond. ISRO aims to establish a sustained human presence in space. Central to this vision is developing an Indian space station. The space station will enable microgravity research and Earth observation. Collaboration with global partners will accelerate technological development. ISRO also plans a human mission to the Moon and robotic exploration. Advanced technologies like reusable launch vehicles are in development. These goals reflect ISRO's commitment to space exploration and India's leading role. India among the stars, a legacy of ingenuity, inspiration, and global impact. From a newly independent nation to a space exploration leader, India's journey is remarkable. ISRO's story is about ambition, ingenuity, and scientific pursuit. ISRO's success has inspired millions globally, showing that innovation knows no bounds. Using space technology for societal good, ISRO addresses real-world challenges. ISRO's partnerships highlight the importance of international cooperation in space. Embarking on bold missions, ISRO carries the aspirations of a nation.